All right, we're going to simplify the expression. Cosecant theta, secant theta, minus cotangent theta. So you're going to simplify it. To start simplifying, let's turn it into the simplest trig functions. What are the simplest trig functions? Sines and cosines, right? Because even tangent can be made out of sines and cosines. So let's just turn each one of these into a sine or a cosine. So cosecant, that's 1 over sine. Secant. Secant is 1 over cosine. Minus cotangent. Well, tangent is sine over cosine, so cotangent is cosine over sine. The parentheses aren't necessary in this, but every time I do this step, I like to put parentheses just to make sure that I'm not mixing things together that shouldn't be mixed together. All right? All right, so now I have on the left, I have 2 fractions. What am I doing with them? Yeah, multiplying 2 fractions, right? So I'll go ahead and multiply them together. So 1 over sine cosine. Minus cosine over sine. Okay, so now I have 1 over sine cosine minus cosine over sine. So now I have 2 fractions, and I'm subtracting. So if I want to subtract fractions, I need a common denominator. The left side has sine cosine. The right side only has sine. So that means I need to multiply the right side, top and bottom, by cosine theta, so that they have a common denominator. So now I have 1 over sine cosine. I know I'm not saying theta, but I am writing it. I just don't like to say it over and over. Minus, I have cosine times cosine. That's cosine squared. Theta over sine cosine. And it's very tempting to skip little steps like this and just put stuff together, but that's where you end up making mistakes, is by skipping the little steps. Yes, it's writing it one more time. But isn't it better to write it one more time in between than have to start over the whole problem because you made a mistake and can't find the mistake? I'd rather just write it out. Okay. So then the next step. I have a common denominator now, so I can put the numerators together. So I have 1 minus cosine squared theta on top. And on the bottom, I have sine theta, cosine theta. Okay. And what does that look like on top? Because I can't just do regular simplifying stuff that I've always done anymore, because it's all smushed together, combined together as much as I can combine it. Whenever you get to that point, pull out your formula sheet. Does it look like anything on the formula sheet? Kind of does, right? Like it has a cosine squared in it, and it has a 1 in it, and it has a plus or a minus sign. So that looks a lot like Pythagorean identity, right? But not quite. So what you're going to do is you're going to take this and be like, that looks a lot like Pythagorean. Well, what is the Pythagorean? Over to the side. Let's see if we can make the Pythagorean identity look like what we have. So I'm just going to come over to the side, write out exactly the Pythagorean identity, cosine squared theta plus sine squared theta equals 1. And see if I can rearrange this to match what I have. Well, the 1 and the cosine are together. And then, so I need to move this cosine over. I'm going to subtract cosine squared theta from both sides. So now I have sine squared theta equals 1 minus cosine squared theta. Now, it matches, right? And remember, an identity is a mathematical synonym where you can change it out. If you have something messy and it equals something that's not so messy, you could take the nicer side and put it back in. So I took the Pythagorean identity, I rearranged it, and now the right side matches what's in my problem, but it's complicated. The left side is the simpler, nicer side. I'd rather have that in my problem. And because they're equivalent, I can do that. So I can take this ugly side out of my problem and take the nice side and put it back in my problem. I could switch it out. That's the whole point of an identity. So this next step, I'm going to have sine squared theta on top because I just switched it out. And I didn't do anything to the bottom. It's sine theta, cosine theta. So now I have a single fraction instead of a binomial over a common denominator. And now I have sine squared on top and I have a single sine on bottom. Well, that's nice because I can cancel one of these with that one. So now I have sine theta over cosine theta. And what is sine theta over cosine theta? Tangent theta. Done. So we just took this expression from the beginning and found out that it's really just equal to tangent theta. And isn't that a lot nicer? Like if we were working some really big problem, maybe it's like a whole sheet of paper worth of problem, and this was part of it, and we could simplify it down to just tangent, that'd be pretty good, right? Like, and make our problem a lot smaller. That's the point of this, is you can take complicated things, and sometimes they simplify down to be something really a lot simpler. So let's do one, like you try this one. It's the same thing, but another expression. It's like the same process. But you do it on your own. And I made it x instead of theta. Tan x sine x. So secant x minus tan x sine x. Simplify it. What is it? So I always start the same way. Make it sines and cosines.
You had to figure out like what it looks like.
No, just for the top. You would have to make the top. I can make that one like the top.
Oh, sorry.